These are the lecture notes for the cardiovascular system, and the cardiovascular system is going to be taken from chapters 11, 12, and 13. Chapter 11 is on the blood, chapter 12 is the heart, and chapter 13 is on the blood vessels. So I will include probably the majority of the information from chapters 11 and 12. But let's go ahead and start with chapter 11 on the blood. And I'm going to skip the learning outcomes. Okay, so the cardiovascular system is the main function is internal transport. It includes the heart, the blood, and the blood vessels. During the embryo's life, and remember the embryo comes first before the fetus, so it's the first organ system to become fully operational during embryonic life. Blood transports nutrients like glucose and amino acids, oxygen, and also carbon dioxide, waste products, and carbon dioxide would be a waste product. And then chemical messengers like hormones. Blood regulates interstitial fluid pH and ion composition, restricts fluid loss at injury sites, defends against toxins and pathogens, and stabilizes body temperature. So you will need to know the composition of blood. Whole blood consists of the liquid matrix of the blood is plasma, and it makes up about 55% of the blood volume. And then the formed elements are the cells and fragments of the blood. The formed elements include red blood cells, white blood cells, and platelets. And together they make up about 45% of blood volume. Males and females differ in the average amount of blood that's found in the body or the blood volume. And mainly this difference is because males tend to be bigger than females. But the average for adult females is 4 to 5 liters, and for adult males is 5 to 6 liters of blood. The blood temperature is 38 degrees Celsius, slightly above body temperature. If you want to look that up in Fahrenheit, it's slightly above 98.6 degrees Fahrenheit. Blood is 5 times more viscous than water. You've probably heard the saying, blood is thicker than water. More viscous and thicker mean similar things. So viscosity refers to thickness, stickiness, and resistance to flow. The pH is slightly alkaline or basic, and it ranges between 7.35 and 7.45. And if you'll remember from chapter 4, blood is a type of fluid connective tissue. Now some medical terminology type things. Whole blood is usually collected from veins. This is called venipuncture. And the vein that is used most often is the median cubital vein in the elbow, or in the bend of the elbow. It's called the median cubital vein. Make sure you know the name of that vein if you didn't already. The reason that we use veins for collecting whole blood is that they are more superficial. They're closer to the skin. They have thinner walls and lower blood pressure than arteries. We wouldn't want to stick an artery because we have blood spraying everywhere. Blood can also be collected from peripheral capillaries, like at the fingertip or the earlobe. And this would be used to make a blood smear or to check blood glucose levels. Occasionally, you can collect arterial blood, and that's typically used to evaluate the efficiency of gas exchange at the lungs. but that's not a very common thing. The two components, let's do number 2. The two components that make up whole blood is the blood plasma, which makes up about 55% of whole blood, and then the formed elements, which make up 45%. And venipuncture is a common technique for obtaining a blood sample because the veins are lower in pressure, they have thinner walls, and they are more superficial than arteries. Okay, so plasma contains 92% water, 7% plasma proteins, such as albumin, and 1% other solutes, which can be hormones, nutrients, gases, ions. The plasma proteins are albumins, which are the most abundant and help maintain osmotic pressure of plasma. In other words, they help to make the blood plasma thicker so that water tends to be drawn into the blood vessels instead of leaking out. Globulins like hemoglobin, and also antibodies or immunoglobulins, which are formed in the immune system. Antibodies and immunoglobulins mean the same thing. An antibody is a type of immunoglobulin. And fibrinogen, which functions in blood clotting. So if you take away the clotting proteins, you have serum. So the difference in blood plasma and blood serum is that the serum has the clotting proteins removed. The liver synthesizes more than 90% of the plasma proteins. And other solutes are going to be nutrients like lipids, carbohydrates, amino acids, and vitamins, electrolytes, which are going to include ions like sodium, potassium, calcium, magnesium, chloride, hydrogen, phosphate, bicarbonate, and sulfate. And then waste like urea, uric acid, creatinine, bilirubin, and ammonium ions. Okay, the three major types of plasma proteins are albumins, globulins, and what was the other one? Fibrinogens. What would be the effect of a decrease in the amount of plasma proteins? The blood would be less viscous. It would be less concentrated. So it would be thinner, or the blood plasma would be. All right. The red blood cells account for 99.9% of formed elements. If you ever look at a blood smear under the microscope, you're going to see 1,000 red blood cells for every one of the white blood cells and platelets. They are red because of the red pigment molecule hemoglobin. Hemoglobin is known for transporting oxygen, but it also transports a small amount of carbon dioxide through the blood. About 1/3 of all cells in the body are red blood cells. A red blood cell count is about, in men, it's about 5.4 million red blood cells per microliter. Women, it's about 4.8 million red blood cells per microliter. And red blood cells can also be measured as a hematocrit, or percentage of whole blood occupied by red blood cells. They do this by spinning a sample of blood in a centrifuge, and the heavier cells settle to the bottom. The hematocrit in men is typically 46% and women is 42%. And these differences are mostly due to the hormonal differences in men and women. Men typically have more testosterone. As far as the structure of red blood cells, they are kind of have an indentation on both sides, on the top and the bottom, and that is called biconcave. And let's see, they lose most of their organelles when they mature. So all they're designed to do really is transport oxygen and carbon dioxide through the blood. And they do have, a lifespan of around 3 or 4 months, and then they're recycled and replaced. This is a illustration of a blood smear. And you can see there's the majority of cells on this blood smear are red blood cells, and this is what they look like. The place where they're biconcave, where they kind of have this indentation in the center on both sides, shows up in a blood smear. It almost makes them look like donuts. Do you see what I mean? So all of these are red blood cells, and then the little teeny tiny ones are platelets. Red blood cells are also called erythrocytes, and platelets are also called thrombocytes. I'm looking to see if there are any white blood cells. I don't see any white blood cells on this blood smear. They would be larger than the red blood cells. Hemoglobin, which can be abbreviated HB or HGB, accounts for over 95% of all red blood cell intracellular proteins, meaning that they're inside of the red blood cell. Hemoglobin is composed of 4 globular subunits, and each subunit contains a heme molecule with an iron atom in its center. And each iron atom can transport an oxygen molecule. So anemia is reduction in the blood's oxygen carrying capacity. It's caused by a low hematocrit, meaning a low percentage of red blood cells compared to the rest of the formed elements. Symptoms of anemia include muscle fatigue and weakness and general lack of energy. A lot of people think of anemia as being related to iron, and sometimes it is, but sometimes it is not. Let's see, the lifespan of a red blood cell is about 120 days, so that's about 4 months. The recycling of hemoglobin, let's see, let's start down here in the middle. Hemoglobin breaks down in the blood. The individual polypeptide chains are filtered by, because hemoglobin is a protein, they're filtered by the kidney. Hemoglobinuria is red or brown urine caused by large numbers of red blood cells breaking down in the bloodstream. And this is the steps of hemoglobin recycling. Iron is extracted, well, first of all, number 1, globular proteins are broken into amino acids. Iron is extracted from the heme molecules. The remaining heme is converted to green biliverdin. Biliverdin is converted to orange-yellow bilirubin. The liver absorbs bilirubin and releases it within the bile. And in the large intestine, it is converted into the biliverdin is converted into urobilins and stercobilins, which gives feces the brown color. And some of the biliverdin gives the urine the yellow color. Jaundice occurs. The symptoms are yellowish skin and eyes. This occurs because there's an excessive level of bilirubin in the blood. It is a result of blocked bile ducts, either due to gallstones, failure of the liver to absorb or excrete bilirubin, or hemolytic anemia, which involves excess red blood cell breakdown. And it can happen in babies as well. And that can be, you may have had an experience with this where they will put the baby under an